for the first operation using the built-in work stop to locate it, and then have a second step in the soft jaws to clamp it for the second operation. So after my second cycle, I get my first finished part out, which can be a huge advantage if someone urgently needs these parts. And there's also a big advantage when you get to look at your finished workpiece and make sure that the work you've done in the first op is correctly aligned to the second op, and you've drilled that hole deep enough and you haven't left a great big burr and only found out after 100 cycles and have to run the whole lot through the first operation again, which I've actually seen happen.
Mazak have recognised that automation is an integral part of our future to become more productive and really get the most out of the machines, to the point now where on the next generation of Integrex they've got a flat front of a design aesthetically, and that's to work better with automation so you can position the robot wherever is most suitable.
So that there's lots of evolution going on behind the scenes at Mazak in regards to automation.
I think there absolutely is. I mean, if you look at our latest 5-axis machines, they've got a rotated trunnion, so you can load and unload from the side of the machine, but still use it with an operator in the daytime, for instance.
And is the same ethos still, you know, with the Integrex done in one, that done in one ethos that you're so proud of? Is this the product for that?
Well, this proves the point. You know, we're taking parts there that are raw material and we're delivering finished parts there onto a separate pallet. So that is the whole ethos about an Integrex multitasking machine.
Okay, so roughly about 85% of all the material we cut is stainless steel 316. My favourite material to work with, to be fair, it's lovely material. Typically we are trochoidal everything. We don't use any traditional toolpaths. Everything is very cam driven. We simulate a lot of our jobs on the computer, check for collisions before we bring it out to the machines. We do a little bit of shorthand programming. Anything on the lathe is normally do right on the lathe. It makes a bit more sense. But anything complicated, we'll always drive down the cam.
And with 0-point system, you've got rigidity, you've got accuracy, you've got repeatability.
And you're doing all of that when the machine's running anyway, so
Exactly.
that's like a double plus point.
Yeah, so you can work on everything here, obviously just like a standard pallet system.
Yep.
So this processability is really important. Work holder repeatability. Now, you also need tool holder repeatability, okay?
Okay, so we've got all the tool holders around here.
Yeah. So here at RNG, they're running the full weekend lights out. So that's a 48-hour cycle, which is absolutely huge. Over those 48 hours, the spindle is turning constantly. Now, you imagine how much tool wear is going to be produced as a result of that. You need to make sure that your tool holders are holding your tools with as minimal run out as possible, so your tool wear rate is as low as possible, okay? So it's all about repeatability in your tool holder system as well.
This is our Integrex i300S. We're well known for the multitasking Integrex machines in the industry. This is designated AM for additive manufacturing. So here we're doing material deposition and material removal on the same platform. Hence the green colour scheme. So when the laser is depositing the material, you're not getting the laser flash. So again, it's a hybrid machine, material on, material off, working with our suppliers of powders, different materials, because it's a technology centre.
Yes.
Machine tools are part of it, application engineers are part of it, but our suppliers are key in supporting us with CAD/CAM, automation.
But you do so much. You do so much. You come from one machine, you know, as we started, you're literally covered in the whole breadth.
We've got about 18 machines in here. We've got over 300 in the range.
We normally talk about the technical abilities of a lot of the machines within the group, Lee, but now, quite interestingly enough, and it doesn't happen very often, we've got some stock machines that are available from Hecker in Germany.
We're looking at a machine today, the CV5 500, which we did look at when it was first launched. Today it's got the addition of automation, and we're going to talk about that.
I've noticed, if you take for instance something like what a lot of people would look at as a 5-axis sort of workpiece where you need to hit all 6 sides of a job and you'd like to maintain a good relationship between the operations. I mean, a lot of the time when you see people using 5-axis machines, they use a centric gripper of some kind and they just clamp a single workpiece. Whereas another way you could do that is by having multiple operations on a table on a simple 3-axis machine and maximising your working area.
Guess what? Star have an exciting competition where you can win one of these. All you have to do is guess the combined cycle time of all of the 16 components here in front of me that make up the Star Saber. In true MTD fashion, obviously we have to find out about the engineering that has gone into the Star Saber first.
I'm Alec Warner, I'm the Operations Manager here at Star GB. This is the Star Saber. This is Mark III Star Saber, so we've been doing these since 2016 and we've absolutely smashed it out the park with this version. On this version there's 16 really challenging parts, all done on Star machines ranging from the ST38 down to our SB20RG. Like previous versions, this version also lights up with the electronics that we've built into it. Regarding the engineering, the most challenging parts are done on the SR38, these two. We've got the body, various machining operations, balance milling, balance turning, engraving included, and the hilt at the bottom of the Star Saber. Again, balance turning, balance milling, lots of milling on the back end. The next 2 parts are done on the ST38. Again, deep hole drilling, threading, milling. This is the coupling part. Again, a little bit simpler, but various operations in turning, grooving and threading. Then we go to the SR20J2. We've got a red acrylic plastic component, and again these side extensions in aluminium. These components here were done on the SR20R4, prismatic machining, engraving, and finally we've got the shaft component, which we actually did on an SB20RG. Long parts mode, ideal for doing this type of component. We really love a challenge here at Star GB, and this version really pushed the capabilities of not only the engineering team, but our machines as well. So I'll be really interested to see what guesses come in.
It's simple. Click the link below with your cycle time guess and you'll be in with a chance to win one of these Star Sabers.